Before watching this lecture, you should know about dummy variables, how to add dummy variables to a regression, and the interpretation of the parameters in front of dummy variables. So this lecture extends the idea of dummy variables by looking at interactive dummy variables. So remember, an interactive variable in econometrics is nothing but a product of two existing variables. So an interactive dummy is a product of a dummy and an ordinary variable. So here's the definition. You take the product of a dummy variable di and an explanatory variable xij, where j is any number from 2 to k. Since di can take the value 0 or 1, this interactive dummy variable can take the value 0 or xij. Here's an example. We have experience, gender, school, number of years in school, and wage for a number of individuals. And we have turned gender into a dummy variable by coding male as 1 and female as 0. So let's create a dummy interactive variable. And you can do that with any of the two explanatory variables. So you can create an interactive variable with experience or school, which is your dependent variable. So let's do, for example, dummy variable times school. Like this. So I just take the product of the dummy variable with number of years in school. Copy this down. And we see that the result is a variable that's precisely the same as school for male. It's the number of years of school for male, while for the other group, female, it's 0. So the idea now is simply to add this to our regression model. So I start with a bunch of explanatory variables, and to this model I add my interactive dummy variable. That's di times xi2, for example, if I create an interactive dummy variable with di and the second explanatory variable, or the one called x2 at least. And I have called a parameter in front of this variable gamma. So let's investigate this and figure out why you would do something like this. So let's say that my initial model is yi beta 1 plus beta 2 xi2 plus beta 3 xi3, where these could be anything, but in the example this was wage, experience, school. To this we add an interactive dummy, so let's call that gamma, and I did it with the school, so di times xi3 plus an error term. So let's look at this regression and see what it evaluates to for the two different groups. So for women, it says yi beta 1 plus beta 2 xi2 plus beta 3 xi3, and for women di 0, so this entire extra term will go away and we just have epsilon I. For men, the beginning is the same, beta 1 plus beta 2 xi2 plus beta 3 xi3. For men, di is 1, so the term becomes gamma xi3 plus epsilon I. So I have one constant beta 3 times xi3 here, and another constant gamma and xi3 here, so I can collect my terms. I can write this as beta 1 plus beta 2 xi2, and then I can combine these two. beta 3 plus gamma xi3 plus epsilon I. So let's compare these two expressions, the expression for men to the expression for women. And we see that the difference is in this term here. It's beta 3 here, and for men it's beta 3 plus gamma. Remember that in a linear model, beta 3 is the marginal effect of x3 on y. So the marginal effect of x3 for women is beta 3, while the marginal effect of x3 for men is beta 3 plus gamma. So as you can see, the entire purpose of adding this interactive term is to allow the marginal effect of schooling to be different for men and women, and to allow the data to estimate these two different marginal effects. If we draw a picture, we see that men and women in this model, they have the same intercept. So if I draw wage as a function of school, and I create this graph for a particular level of experience, so xi2 is fixed, then for women the slope is beta 3, so it looks perhaps something like this. Increase of 1, increase of beta 3. And for men the slope is beta 3 plus gamma, so it's either bigger or smaller depending on the sign of gamma. But if gamma is positive, then we have 1 and beta 3 plus gamma. That's for men. So simply the model allows the return from additional year of schooling to vary between these two groups. Estimation is pretty straightforward. We do model, ordinary least squares. We need to create the interactive dummy variable. So we do plus here, and we call it something, perhaps male school. And it's just a product, male times school. And then we just add it to our regression model. So wage is explained by experience, that's x2, x3, and my interaction dummy, like that. This is the result. This is the intercept. We have assumed a common intercept. This is the return of experience. One more year of experience will increase the salary by 0.13 approximately, holding school and gender constant. This is the marginal effect of school for women. One more year of school will increase salary by 0.57 for women. This is the estimated gamma parameter, and it's simply the extra slope, the extra marginal effect for the group coded as 1, men in this case. So the marginal effect of school for men is the sum of these two, 0.69 or something. We can test if there is a significant difference in the marginal effect simply by testing if this is significantly different from 0. We have a p-value which is exceptionally small, so that is rejected. In this data, the return for schooling is higher among men than among women. So to summarize the whole thing, the marginal effect of individuals coded as 0 will be beta 2. This beta 2 in front of xi2 is the marginal effect of x2 on y. The marginal effect of x2 on y among individuals coded as di equal to 1 will be beta 2 plus this additional parameter gamma, leaving us with the interpretation of this gamma, the parameter in front of the dummy interactive variable, as the extra marginal effect that group 1 individuals enjoy above the marginal effect for group 0. Just keep in mind to have the correct view of marginal effect here. It is not the marginal effect in the sense that we hold everything else constant. It's just the marginal effect in the sense that we hold the other x variables in addition to x2 constant. So let's look at some extensions to this idea. The first sort of trivial extension is that you can create many interactive dummy variables. In my example here, I created an interactive dummy variable between dummy and school. I could have created one between dummy and experience as well. And if you have many dummy variables, let's say you have additional dummy 2, then you can of course create interactive terms between dummy 2 and experience and dummy 2 and school as well. So that's one extension, many dummy variables. Here is another example where we have two interactive dummies, one between the dummy and x2 and one between the dummy and x3. The interpretation will be very similar, namely beta 2 is the marginal effect of x2 for group 0 individuals. Beta 3 is the marginal effect of x3 for group 0 individuals. The marginal effect of x2 for group 1 individuals is beta 2 plus gamma 1. So gamma 1 is the extra marginal effect of x2 for the group of individuals coded as 1. And the marginal effect of x3 for the group coded as 1 is beta 3 plus gamma 2. Gamma 2 being the extra marginal effect for individuals coded as 1 above the marginal effect for individuals coded as 0. Another possibility, which is quite common, is to use both regular dummy variables and interactive dummy variables in the same regression. So I could do this. I could do beta 1, and then here I add the dummy variable with a constant of gamma 1, and I add the interactive dummy variable with a parameter gamma 2. That will allow the slope and the intercept to be different between the groups. If I had done that in my example, just as an example, I've done school, wage, then beta 1 would be the intercept for women. They would have a slope of beta 3. Gamma 1 would be the extra intercept for men, so their intercept would be beta 1 plus gamma 1, and they would have a slope of perhaps something else, beta 3 plus gamma 2. So by including a dummy and an interactive dummy, you allow for both the slope and the intercept to be different.